Okay. So I'm now live on YouTube. So if my meeting is full, then they can also basically join from the YouTube as well. Okay, cool. So recording is going on. Okay, guys. So let me just tell you. First, I will tell you about ourselves. Okay, so we are basically from Skilled Inspirational Academy. And if you want to check, if you want to know about us, you can basically go to into that website, cnets.com. This is our website where you will get all the details regarding us, how we will basically, these are the courses which we generally use to cover, and we have our trainings for them. Apart from this, we do have an application as well on Android and your iPhone. So this is the particular application, Skilled Inspirational Academy. You will get the link from my team regarding that application. And we do have two YouTube channels. This is our first YouTube channel, Skilled Inspirational Academy. Here you will get some F5 related stuff and some FortiGate, AWS, such kind of stuff is there. We do have another YouTube channel with the name of NST Firewalls. Here also you will get Palo Alto related stuff and your AS related stuff, VPN related stuff. Okay. So this is our details. If you want, you can basically check out these details now. Let me just tell you how I will basically run through with this training. So I will first go through generally what are the things I will basically cover in this training. So if you have seen here, it's around 32 plus hours of training. And guys, in this training, basically, I will cover both theory plus practicals. And guys, I am basically working on Palo Alto. I'm having around 10 plus years of experience. I'm also a PCNA CNCC certified. So the thing is, I will basically give you the details how Palo Alto works, how we can deploy it on the production environment. Okay, it's not like that I'll just run through with the theory and some basic labs. No, you will get the advanced labs here. Okay, you will also get the lifetime interview support. So let's suppose you have an interview on Palo Alto Firewall or on F5 LTM. You can call us around 4 days before, and we will basically arrange a call with you and we will take your mock interview. You will also get one lab workbook. That workbook basically you can refer for lab setup, and also this workbook contain all the theory stuff. Let's say you have an interview, then if you want to cover Palo Alto very fast, you can go through with this particular lab workbook. You will also get the lifetime recorded videos. So after every session, we will record every session and we will give you the access of these recording sessions for lifetime. Okay. We will also help you building the lab on your laptop. Let's suppose you don't have a good laptop. So generally for Palo Alto, you need a laptop of 12 GB RAM. Okay. But or either if you don't have a good laptop, then we can basically use the Google Cloud platform for the same. So in Google Cloud, you just need one credit card. And if you will subscribe for Google, you will get the 300 USD as a free credit for 3 months. So you can use Google Cloud 3 months actually freely. And all the lab, I will basically help you building in your VMware workstation. And I will also help you the installation of EVNG. All the necessary softwares, whatever you need, everything we will basically share with you. Generally, it's a weekends classes, and your classes only happen on Saturday, Sunday, and the timing is 9 a.m. to 11 a.m. That's the timing of your classes. We will also help you with the mock interviews for every student, guys. So this is the thing which I will basically cover in this particular training. Now, let me go through with the course content. What is the course content I am gonna cover in this training? So if I'll go here, so generally this particular course content I have divided into 14 classes. In your first class, I will explain you the platform and architecture. your SP3 architecture or your single pass architecture, your flow logic, or we can say life of a packet on Pan OS. So if I'll talk about the platform and architecture, right? So if you know, when Palo Alto basically sell their solution to any customer, they will say Palo Alto supports SP3 architecture. So here basically I will cover everything with regards to your SP3 architecture, how this SP3 architecture is implemented on Palo Alto firewall, how your Palo Alto firewall process the packet parallelly. Let's suppose we have received 3 packets for the same session. Now, how my Palo Alto firewall process this packet? How many CPUs basically we have on each and every platforms, right? So we will discuss different platforms like your hardware models. We have a like 200 series firewall, then we have a 800 series, we have a 3200 series. In between, we do have a 3000 series as well, right? But that series is end of sale now. We have a 5200 series, but there is a few data center you will also see 5000 series, right? What is the difference between them? So such kind of things I will cover in your platform and architecture. Then we will go through with the single pass architecture. In flow logic, basically I will discuss different stages of your packet on your Palo Alto firewall, how Palo Alto firewall do the process, what are the checks it will basically do into the ingress state, what is the flow lookup stage, what is slow path, what is fast path, what is app ID, what is content ID, what is your forwarding stage, how Palo Alto firewall process everything, where basically it will store the packet. So everything we will see in detail. Then I will basically move, after that I'll just move towards your initial configuration. Means, let's suppose you're working on Palo Alto devices and now you receive a box, right? Now, what are the things you have to basically configure on that box? What is the initial configuration? How you can basically bring the management interface of Palo Alto up and running? How you can basically configure the SHS and HTTPS services on Palo Alto, how you can restrict that particular access, what is the default username and password, what is the default IP address, right? All these things we will cover in detail in your initial configuration, initial access of the system, where I will tell how you can basically connect with your Palo Alto firewall using console cable, right? If you are working remotely, then how you will basically guide your field engineer who is visiting the site, right? How you can basically do the rack and stack activity. Rack and stack includes how you can rack mount this to the Palo Alto firewall. How basically when this FE, he is connecting the Palo Alto firewall with the switches, right? How you can make sure he has made the correct connections, right? On the correct port, how you will make sure, right? So I will tell you the ways, and also I will tell you how you can make a CLI scripts for that particular thing. Let's suppose you want to deploy this firewall at 100 locations, Palo Alto. Now, how you can basically create a CLI template. So for each and every location, you just need to change the IP address and other things remain same, right? Because your jump server, your radius server, or your AAA server, your backup servers, all these things remain same, right? For each and every location. So how we can create this CLI template? Then I will move towards your configuration management. Here we will discuss when we shape the configuration or when we run the commit command on Palo Alto, how commit works. If your commit is failing, where we generally check the log file, right? Everything we will see in detail. Like in commit, if I'll say, in Palo Alto, commit happens in 3 phases, and where you can see all these particular logs. So generally, I will tell you which is the log file you have to basically see for that, right? So everything we will see in details. What is the log file we have to check. What is the difference? So how we can read these particular logs and all, we will see everything in detail. What are the different commands we can use for that, okay? So we will see all these particular things in detail. Okay. How we can use the grep command, how we can use the pattern, everything we will see in detail here. And after that, I'll just move towards your licensing and software upgrades, where I will tell you what are the different ways you are having to license your Pan OS, right? Generally, the first thing what you have to do, when you got a new device, you have to register your Palo Alto firewall into the Palo Alto support portal, right? And after that, you have to activate your license by using auth code. And after that, what? Either you can download the license file and you can manually upload on the firewall. This is the one way, right? The second way, if your firewall is having the internet connectivity, you can directly fetch the license details from the support portal. But in the good organizations, you will not get the direct internet connection on your Palo Alto firewalls, right? So how you can basically upload these files to the JUMP servers, what are the ways? So everything we will cover in detail. Now, after that, I'll just move towards your account administration, how we can basically create a different users like on the basis of their level, like how we can create a L1 users, how we can create a L2 users, L3 users, and we can restrict the access level also of these users, means how we can manage the authentication and authorization levels of these particular peoples. So we will see all these details here. Vidit sir, can you just approve the people? Some are waiting on the chat room, please. Okay, now after that, I will also tell you how we can basically use the Radius server or your Active Directory server for basically this particular username and password management. Then what is the admin rules, how we can create a different rules types on the basis of L1 users, L2 users, L3 users, contractors, right? Then we will, after that, I'll just move towards your interface configuration, how you can configure the interface by using the CLI and by using the graphical user interface. Because if you want to do the configuration very fast, you have to know the CLI of your Palo Alto firewall, right? How we can, what is the concept of security zones? Then I will move towards what is the layer 2 deployment? What is layer 3 deployment mode? What is virtual wire deployment mode? What is tap mode deployment? And all these deployment we will discuss with the use cases on which scenarios we will basically go for these particular deployment. And in the production environment, you will see around 98% deployment, you will use layer 3. But I have also seen 2% customers, they are also using virtual wire deployment. Okay, then I will explain you the concept of sub-interfaces, how we can create a sub-interfaces on your Palo Alto firewall. Then I will move towards your DSCP, how basically Palo Alto's act as a DSCP client, act as a DSCP server, and act as a DSCP relay agent. How we can basically configure all these things on your Palo Alto firewall. Then we will basically move towards your virtual routers, how to configure these virtual routers, because in your Palo Alto firewall, if you want to configure the routing, you have to basically go with the virtual routers. What is the concept of multiple virtual routers? How we can enable the routing between multiple virtual routers, right? So this part I will cover in detail here. And after that, I'll just move towards your multi-VR setup and use cases. Then I will move towards the most important topic of your Palo Alto firewall is your securities and your net policies. Security policies and net policies, how we can basically create the security rules, how we can create the net rules, right? By using graphical user interface, by using CLI, right? How we can basically manage, or how we can do the policy administration, right? How we can use the tag for segregating the policies, right? Everything I will basically cover here in detail. Now, if I'll say net, right? In net, basically I will cover what is your dynamic net, then what is your port address translation, or what is your PET, what is uternet, what is your destination net, right? Everything we will cover in detail. So means here I will cover all kind of use cases of net in Palo Alto firewall. And after that, I'll just move towards app ID. What is application identification? Because Palo Alto is the first firewall who has introduced the application identification. And Palo Alto is the #1 firewall. He is the market leader due to app ID feature as well. Okay. Then what is app ID overview? how basically application identification happens on Palo Alto Firewall. What is application signatures, right? How you can basically download these signatures, everything I'll cover in detail. How my Palo Alto Firewall basically process your TCP packets for app ID. How your Palo Alto Firewall process my UDP packets for application identification. Then we will see what is application groups, how we can create a filters. Like let's say you want to block all the risk level 5 application. What we can create one filter. We can create application group. Let's say I want to block your YouTube, Netflix, right? All these media streaming applications, right? I can create the group as well. Then I will move towards your content identification. So in content ID basically, or we can say your Palo Alto CTD engine, it includes your antivirus protection, anti-spyware protection, vulnerability protection, URL filtering, external dynamic list, file blocking with wildfire, security policy of file blocking, then wildfire, right? So all these particular features, they comes under your content ID. Now, how your content engine triggered on Palo Alto Firewall, how basically we can configure these different security profiles for getting the security, right? And I will basically give you one dedicated lecture on URL filtering where we will cover everything with regards to URL filtering, how Palo Alto Firewall URL filtering works. Everything we will see in detail. I will also cover what is external dynamic list, how EDL's configuration, how EDL works, right? And I will also explain you what is wildfire operation, how my Palo Alto Firewall protect you from the real-time attacks. Or if let's suppose there is a new malware in the market. Now, how my Palo Alto Firewall protect you from this new attack or new malware, right? So this is only able to happen through the wildfire feature of Palo Alto. How we can configure, how we can basically configure it, how it works, everything we will see in detail. And after that, I'll just move towards your zone protection and DOS protection, guys. In zone protection and DOS protection, if I'll say, so let me just go back here. Yeah. So in zone protection and DOS protection, we will discuss in details, guys. And in this particular class, I will use my Kali Linux machine. And what I will do, I will launch the real-time attacks. And I will show you if I can I will launch the attack from this machine and I can show you how I can basically increase the CPU utilization of Palo Alto. How I can basically decrease the performance of your end server by launching the SYN flood attack, UDP flood attack, ICMP flood attack, other IP flood attack, how I can configure the IP spoofing or hot switch kind of attacks here, right? Everything we will see in detail. And after that, I will also configure zone protection and we will see how due to zone protection or DOS protection, we are getting the protection here. Right? So we will see in detail. Then I will move towards the most important topic of your Palo Alto Firewall, which is your decryption. Or we can say your SSL decryption. Here I will tell you how my Palo Alto Firewall decrypt the SSL traffic. Either it is going towards the outside, so outbound SSL decryption, or forward proxy, or inbound SSL decryption. How basically we can configure, and I will also give you the detailed overview of your SSL handshake. How SSL handshake happens, and when we configure the outbound SSL decryption on Palo Alto Firewall, how this particular SSL handshake is implemented on your PAN-OS, how your PAN-OS process this thing. What is the concept of FPTCP segment? What's that? How your SSL engine inside the Palo Alto kick in, right? And if there is a session on proxy, how you can check the logs and you can see, oh, this session is in proxy, right? Everything we will see in detail. And I will also give you overview of your certificate management. Then I will also explain you what is SSH decryption, because nowadays, guys, most of the attacks happens through the SSH tunnels. People used to create SSH tunnels, and after that, they will basically send their traffic inside this SSL tunnel. So we will see how basically you can basically prevent such kind of attacks if someone is trying to exploit by using the SSH tunnel. Then I'll move towards your user ID. What is user identification in Palo Alto Firewall? In this user ID, I will cover how you can integrate your Palo Alto Firewall with Active Directory. What is user to IP mappings? What is user ID agent? How we can install the user ID agent on one of the member server, and how we can use the inbuilt PAN-OS user ID agent, right? So we will see in detail, and in user ID, basically, I will tell you according to your requirement, what is the configuration you have to do inside your PAN-OS? Because I have seen there are just requirement for user to IP mapping, but people have done everything. They have done the LDAP integration, right? They have created the group mapping and everything, but they're not required, right? At all. So I will explain here what is the exact implementation of user ID in your PAN-OS. And after that, I'll just move towards the most important topic of your Palo Alto Firewall is IPsec site-to-site VPN, where I will discuss in detail your phase 1 and phase 2 exchange process. What is IPsec tunnel? And guys, if anyone, if they are having some idea on IPsec VPN, then they should know if I will use main mode in phase 1 and quick mode in phase 2. Then in main mode we have 6 messages, and in quick mode we have 3 messages, right? And if I'm using aggressive mode in phase 1, then there is a only 3 messages, right? So in main mode, if you remember from message number 5, 6, right, then these 3 messages 7, 8 and 9, these messages always go in an encrypted form, right? But I will tell you the ways how you can decrypt these particular messages on your Palo Alto firewall, and how you can verify these particular content of these messages. And if you have seen message number 3 and 4, right, these message number 3 and 4 is known as a Diffie-Hellman exchange, right? And Diffie-Hellman exchange generally be used for generating your keys, right? So then here I will explain you how my Palo Alto firewall do the calculation of your keys, how it will calculate the Diffie-Hellman key, DH key, how it will calculate your SKID D derivative key, then SKID A, which is your hashing key, then SKID E, which is your encryption key, how all these keys will be created by your Palo Alto firewall, right? Everything we will see in detail. Even though I will also tell you how you can decrypt the ESP messages, right? Because you have seen we cannot able to decrypt the VPN packet, but I will tell you the ways you can able to decrypt your VPN traffic as well. You can able to decrypt the ESP packets, and you can able to see everything inside these particular messages. And in IPsec VPN, because this is also my favorite topic, guys. So here I have mentioned around 13 use cases of VPN, like IPsec site-to-site VPN configuration between 2 Palo Alto devices having a static IP. And here I will use pre-shared key. And another use case, I will basically use the certificate instead of pre-shared key. So this is the second use case I will cover. Then third use case, if you are having the overlapping subnet on both the end, then how you can configure the VPN and you can enable the connectivity between them. If let's suppose one device having a static IP and another device having IP address from DHCP, how you can basically configure that part, right? If let's suppose one peer or one firewall behind the net gateway, how you can able to configure the IPsec VPN, how it works, everything we will see in detail. Then how you can configure the IPsec VPN in case of dual ISP, like one tunnel is in active state and another one is in backup state or in standby state. How we can configure the failover using tunnel monitor, how we can configure the failover using static route path monitoring, and how we can basically use the 2 virtual router and policy based forwarding to implement the same thing. Then after it, I will cover your IPsec VPN between Palo Alto and ASA firewall. Between Palo Alto and ASA, but this time Palo Alto having the dynamic IP address. Its IP address is not fixed. I will also explain you how you can configure the IPsec VPN using OSPF, which means It's a kind of DMVPN solution. Then I will also cover here IPsec site-to-site VPN, or we can say route-based VPN using OSPF. So it's a like hub and spoke kind of environment. Okay, so all these particular use cases I will cover in your Palo Alto firewall for with regards to your VPN. So it will cover everything which you have to know with regards to the VPNs. Then I will also explain you after that your global protect part, where I will go through with the global protect connection flow, which means when we will connect using a global protect, what is the connection flow? How many SSL tunnel is created and terminated? I can say, as per my knowledge, around 15 tunnels is created and they just got terminated, because Palo Alto Global Protect is a big process and you have to know entire flow. If you know entire flow, then only you can able to teach troubleshoot these issues. Otherwise, you will not able to touch any of these issues. You will not able to troubleshoot them. I will explain you all the deployment of your connection method. Like in Palo Alto, we have a 4 types of deployment for Global Protect. I will cover all these deployment in detail. What is your own on-demand method? What is your pre-logon then on-demand, right? What is your user logon, then pre-logon, then user logon, right? All these particular 4 deployment method I will cover in detail, along with the use cases on which scenarios we have to use which method. Like user logon, on-demand, then pre-logon, then on-demand, pre-logon, then user logon, right? All these messages I will cover. All these particular deployment method I will cover in detail. Then I will move towards your management and reporting stuff. How you can configure syslog server, how you can configure NetFlow, what is log type, dashboard, basic logging, basic reporting, what is Panorama. Then I will basically cover here active, passive, high availability. In Panorama, guys, it's a big topic. If I will take the full Panorama training, I have to take at least 10 classes, which means around 20 plus hours of training. So what I will do, I have created a video based training for Panorama. And what, when you will enroll for our course, you will get these particular 7 hours recorded session of Panorama, and you just need to pay 300 rupees. That's it. We will give you one voucher and you can opt for that particular training. And after it, I'll just cover your active, passive, high availability, because high availability you will see everywhere. Every organization you will see they are having firewalls in HA mode, right? So where I will cover configuration of your active, passive, high availability. What is your active, high availability? How we can configure your active, high availability? In active, HA, basically, generally we have a 3 types of deployment. We can use floating IP based. So we will have a dedicated lab for floating IP, HA, high availability lab on active, ARP load share based HA lab, and mixed mode HA lab. And after that, I will also run through with the troubleshooting webinar, where I will cover your packet filter, packet capture, flow basic, and TCP dump. How we can use these particular utilities for troubleshooting the Palo Alto packet-based troubleshooting. So this is all about the course content, guys. If you want to contact me, this is my mobile number. You can contact me if you have any doubts. Okay. So this is the course content which I'm gonna cover now. Let me just go through what are the lab topologies I will basically use throughout the trainings. So if you will see, this is the first topology which I will use, and this topology I will use for 80% of labs. So around 80% of lab I can able to basically do by using this particular single topology. In this topology, if you will see, I have a Palo Alto firewall, right? Palo Alto firewall Ethernet 1x1 interface. It has a connectivity with my home Wi-Fi from where I'm getting the internet. And in the outside, I am having one Kali Linux machine. And this machine I will use as a hacker system. From this machine, I will launch the attacks on these particular DMZ servers. So I have a Ethernet 1x3, which is my DMZ zone, where I have a 2 servers, and these servers, they are running HTTP, HTTPS, Telnet, and SSH services. I do have a LAN network as well. In LAN side, I'm using Ethernet 1x2, and I have two machines, one Linux machine and one Windows PC. I will use these two machines just for doing the test. And I have a separate or dedicated management interface from which I will basically get the access of my Palo Alto firewall. So this is the one of the lab topology which I will use. The second lab topology which I will use in your sessions. So let me just open that part. So for your high availability, so this is the topology which I will use in your HA classes. So your high availability, like your active HA and active passive HA, I will basically use this particular lab topology, and I will do the practicals here in this particular lab. So we will see how we can basically configure this entire lab topology and how your HA is make sure up and running. In HA, I also give you some advanced concept, right? How basically system daemon on this Palo Alto firewall 1 communicate with the system daemon on Palo Alto 2. What is the HA agent daemon process, right? So we will see how we can verify all these logs, right? Everything we will see in details in your live classes. Okay, now for IPsec VPN, I will use this particular lab where I have my head office Palo Alto firewall, which is this. Then I have a branch office firewall, so branch office 1 and 2. These are my two branches. This is my head office. And I will basically have, these are my internet providers, ISPs, right? Here I have one more ASA firewall where this ASA I will use as a net gateway, and behind this I have a Palo Alto firewall, right? And I do have a one client ASA firewall. So I will use this particular lab for configuring all your VPN related stuff, or all your VPN use cases I will cover by using this lab. And you don't need to create these topologies. I will share these topologies with you now. There is a one more lab which I will use for the redundancy purpose. So this is the lab where we will basically, I will use for redundancy purpose, where I will cover your redundancy, like what is your path monitoring, how path monitoring works, how your policy based forwarding works, how your ECMP works, right? Because generally in production environment, you have a dual ISP kind of scenarios, right? So I will cover all these things in detail by using this particular lab. So these are the lab topologies which I'm gonna use into your sessions, guys. Okay. Now, let me just move towards one of the most important topic of your Palo Alto firewall, which is stateful inspection. What is stateful inspection? How stateful inspection works? Okay. So let me go directly into my whiteboard. Let me make some space here. Okay. So let me just give you one example here. Let's suppose I have one PC. This is my PC. Then I have here one router. So because router is a stateless device and firewall is a stateful device, right? So first we will see how my router do the processing of your packets. Then we will see how Palo Alto firewall process the packet, and you will basically, then only you can able to understand the stateful inspection. Okay. I have a PC1, the router, and I have one of the server here. Let's suppose this is server 1. Let's suppose on this server, I am running some web services. So that server is listening on TCP port 80. And on this server, let's suppose I am having one file of 2 GB. Maybe just a MP4 file. Now this PC, what he wants to download this particular 2 GB of file here. So now how it will do, how this process will happen, guys. So if I write down the things here. So because it's a TCP, right? So in TCP, always this PC, he will send first request, which is a TCP send request, right? He will send the TCP send request. That send request received by this router. Now when this router, he received the request, so what it will do? Now router will basically start processing. Let's say this is F0/0 interface. This is F0/1 interface. So what router will do? Router basically process that packet at ingress level or ingress stage. What it will do? It will receive this packet. It will basically store this packet into the interface buffer, right? Into the interface buffer, which we are having, or we can say it will store into the RX ring of this router, right? And after that, this router, what it will do now, it will basically check this particular packet against the routing table. If you have a net, then it will also check that packet for against the net rules, right? If you have a ACLs also configured on this router now, it will also check this packet against the ACLs, right? Let's suppose you have a quality of service or configuration as well on this router, then it will also check for QoS, right? So in case of router, what it will do, it will send this, it will check that particular TCP SYN packet, it's a first packet against around 27 checks, guys. And at the end, the last check, which is what it will do, it will do the forwarding. Forwarding is the last particular stage in case of this particular router, right? What it will do, after doing all these checks, it will forward that request here to this server. Now this server, he will receive this request, right? This server, he received this request, and after that, what it will do, he will respond. So in the response, what you will get, TCP SYN plus ACK request. Now this request also TCP SYN plus ACK packet. So this is the first packet, right? Now second packet also, it will, in case of router, it will also go through with all these checks. And guys, just remember one thing. In case of this router, the major checks is these. These three, they are the major checks: your routing, your net, and your ACLs. These are the dedicated engines, or we can say instance, we are having on your router, who is responsible for your routing related task, who is responsible for your net related task, and who is responsible for your access control list related task. Right? And these are the major checks. Okay. Now, and after that, what will happen? Now this PC will send the next request, which is TCP ACK request, right? This ACK is also received by this router. This ACK will also go through with all these particular 27 checks, and it will forward that request towards the server, right? And after that, this PC, he will send the request, which is HTTP GET request. That request reaches to the server, right? Then you will get some response here. So let's suppose between this PC and between this server, they have basically done the transaction of 200 packets. Let's suppose from this PC, he has sent 200 requests, and this server, he has basically responded for 200 replies. And let's suppose my router, which is the middle device here, he just need around 2 seconds for doing all these checks, right? I am just taking here hypothetical numbers, guys, okay? And now 200 requests and 200 replies, what is the count? Total count is 400, right? And now from this PC, if he wants to download this 2 GB of file from this server, how many seconds it will need? Or how many seconds is basically needed by this router for processing all these request and reply packets? Around 800 seconds, right? Because every packet will go through all these checks, which will take around 2 seconds, right? Maybe in actual it happens in milliseconds, but I'm just going with the hypothetical number for your understanding purpose, right? So this entire processing will happen in just in 800 seconds, right? Now this is the behavior of your router. Okay. Now let me just now give you some basic idea of your stateful inspection. So a stateful inspection is a feature where a device, what it will do, it will maintain the state table. What it will do, it will maintain the state table. Now, if he is maintaining the state table, which means there is some special or some specific purpose of that particular table, right? So the thing is, when it will maintain this state table, so what it will do, it will bypass few of the checks, guys. What it will do, it will bypass few of the checks. That is the reason, basically, due to this stateful inspection technology or a concept, your inspection behavior of your firewalls is completely changed. Okay. This particular stateful inspection feature is developed by the person, his name is Nirchuk, in 1993. While he was a tech engineer in Checkpoint. So the actual organization who has basically developed this stateful inspection concept is Checkpoint. And guys, this Nirchuk, he's the same guy who is basically launched the Palo Alto Firewall, and he's the CEO of your Palo Alto Firewall. So guys, if you have seen from 1994 onwards, all the other vendors, they have start using your stateful inspection technology. Okay, now let's discuss this particular technology, how it works in case of Palo Alto Firewall. So now I have a same diagram. I have a PC. I have a firewall here. But this time I am having here Palo Alto Firewall. So guys, here I will discuss with regards to Palo Alto Firewall, this stateful inspection, because this particular technology will change, or the maybe tuples of your stateful table will change in other vendors' devices. Okay. Same server who is having hosted on TCP port 80 is also having the same file of 2 GB. IP address of this PC is 10.1.1.70. Or let's take here 10.1.1.70. IP address of this server, let's suppose it is having 20.1.1.70. These are your internal servers. Okay. Maybe this PC, he is in inside zone, and this server, he is in DMZ zone. Now, the similar thing, let me just explain you the how your Palo Alto Firewall do the processing of these requests. And guys, just remember this processing. Okay. If you remember this process, because this is the most important question in interview, when Palo Alto Firewall receive a packet, how it will process, right? So now this PC, he wants to access this server on port 80. So what he will do, he will send one request here. It's a TCP SYN packet, right? Now when this SYN request is received by the Palo Alto Firewall. So guys, now let me tell you some glimpse of life of a packet in PAN-OS. I am not explaining in details, guys. I but just tell you the stages. Now my Palo Alto Firewall, he received this packet, let's suppose in Ethernet 1x2 interface. So what it will do? What it will start the processing. So let me just write TCP SYN packet processing. What it will do? It will first process this packet against ingress stage. After that, it will move towards the flow lookup. Then your slow path. And after that, I'll just make some space between slow path and fast path, guys, because I want to write few more things here. Then fast path, then app ID, then your content ID, then your forwarding stage. Right? These are the actual state of your Palo Alto Firewall when he will basically do the processing. Okay. Just remember your app ID and content ID, they are not applicable for TCP SYN requests. Why? Because in TCP SYN, it is not having any kind of application data. So this packet will not go through your app ID and content ID. Just remember. But I have write all the stages here. Okay. So TCP SYN, it will not go through your app engine and content engine. Now in Silopath, basically what we have a major checks, which are your zone protection and TCP state check, TCP state check. We have a routing, we have a net, then we have a security policy evaluation or net evaluation security policy is also checked against this particular stage only. Your authentication policy is also checked. Again, this stays in Silopath only, right? So in Silopath, we have these major checks, guys. Okay. Okay. Now, so your SYN request is processed like that. Apart from this Palo Alto 5, what it will do when he receive a packet, so ingress stage, then flow lookup. So in flow lookup, basically what it will do? It will do the lookup into your session table. Now what is session table? Session table is equals to your state table, because in a stateful inspection, every firewall, they will maintain the state table. Okay. So now how my firewall maintain the state table? What it will use to do? In Palo Alto firewall, when it will maintain the state table, basically it will store 6 tuples information. What it will do? It will store the 6 tuple information. What are the 6 tuple? Your source IP address, source IP and source port. Means, but it will store your source socket. Source socket means your source IP and source port. It becomes source socket, right? Then your destination IP and destination port. So this become your 4, right? Source IP, source destination IP, source port, destination port, right? So this is your 4 tuples. Then the next one is your ingress zone. Ingress zone means the zone where we have received the request, so which is inside here. And your layer 3 protocol. So for TCP, layer 3 protocol number is 6. So what you will see these particular 6 tuple information into the state table. Okay. Now just come back here. So these are the 6 tuples of your state table. Okay. Now, because when my firewall, he receive a TCP SYN, he has process and he has store all, he has created the session, right? And what after end of the day, what he has done, everything is fine. He just send out this packet towards the server. Now from server, he will give the reply, right? TCP SYN plus ACK. Now, when TCP SYN plus ACK received by the Palo Alto firewall, what it will do? This time your Palo Alto firewall, it will bypass your Silopath. Which means it will bypass your zone protection policy, your routing, your net, your source security policy, your authentication policy, your DOS policies. It will bypass all these particular policies here. So let's suppose TCP SYN, because this syndicate has to go through with ingress stage, then flow lookup, then slow path, then fast path, right? Then forwarding. Let's suppose my file took around 2 seconds. But when we have received SYN plus ACK request, because your major checks is your routing, net, and your security policies or ACLs, right? Because this stage is bypassing now. Why? Because I have created the table, I have created the session table, I have created the flow for this particular session, and I can bypass all the subsequent request and reply packet for that particular flow. And I will not send them to the slow path. I'll just directly send them to the fast path. Which means I'm bypassing the slow path now due to stateful inspection, right? So what it will do, it will process like that, right? And let's suppose in the similar case, this Palo Alto fire between this PC and server, they have done 200 requests and 200 replies, which means total is 400 packets. In these 400 packets, only your TCP send packet, the first packet, which the time taken by the firewall for processing your first packet, which is TCP send packet, is 2 seconds, and remaining packet, because it will bypass the slow path, so it just take 1 second. See the difference now. You just, in case of firewall, you just need a time of 401 seconds for processing this entire transaction. In comparison to router took around 800 seconds, right? And here firewall is taking only 401 seconds. That's a basically difference between router processor and firewall processing. And why firewall is able to do that? Because it is maintaining the state table. Now, why it is maintaining the state table? Because router is a stateful device, or it support stateful inspection. So guys, due to stateful inspection, the inspection behavior of your firewalls is completely changed. That's why this particular technology become very, very popular, and it is adapted by almost all the vendors. Nowadays, whatever firewalls you will see, they have a support of stateful inspection because of this reason. So this is all about your stateful inspection, guys. This is all about your stateful inspection. Now, let me just explain you the next topic, which is SP3. So SP3 stand for single pass software and parallel processing hardware. And guys, there is only one firewall who support SP3 architecture, which is your Palo Alto firewall. So Palo Alto is the only firewall who supports single pass architecture, or it support SP3 kind of architecture, which means if you will see this diagram here, what Palo Alto have done, Palo Alto basically divided its hardware into two parts: your control plane and your data plane. This control plane, or we can say, I can put here the good name, which is management plane. Palo Alto divided its architecture into two parts: management plane and your data plane. He has done that kind of segregation here. And after that, to increase the performance of your Palo Alto devices, what they have done, they have further divided their data plane into three another planes: your network processor, your security processor, and your content processor. Or the best name is your network processor, your security processor, or your signature match processor. And this is the control plane, where you have your management plane. And if you will see these planes, they are having dedicated RAM, dedicated CPU, and dedicated hard drive, which means they don't have any kind of resource level dependency on each other. They don't have a resource level dependency on each other. Okay, which means if there is some DDoS attack is launched by any attacker on your data plane, in that case, your management plane is safe. You don't need to basically, your management plane will not impact. If someone is launch any attack on your management plane, that time your data plane is safe. So such kind of benefit you will get in this kind of architecture. This is the parallel processing architecture, guys. These particular engines, your signature match processor, your security processor, or your network processor, these engines, they have a dedicated jobs to do. In other devices, you will see they are using they just have a one CPU and the RAM. Their resources is shared resources. They have the shared resources. But Palo Alto, all these three processors, they are having dedicated resources. So if any of the resource or any of the processor is busy in the processing, he is not having the resource level dependency on other processors. So that's why they can able to work independently. That's the benefit of your parallel processing hardware. Now, one more benefit you will get. Let's suppose in Palo Alto Firewall, guys, just remember your PAN OS or Palo Alto Firewall operating system. It's a customized version of your BSD Linux. What they have done, they have taken the BSD Linux, they have done some customization, and on top of this BSD Linux, they have just installed their PAN application service. And the entire thing is called as a PAN OS. So guys, just remember, because this Palo Alto operating system is a BSD Linux based, means its kernel is the Linux in a backend. So your management plane, which is this part, it's a Linux environment, guys. And if you know in Linux, if someone is familiar with the Linux, basically in Linux, there is a daemons, right? Or processes are running always. Let's suppose you have configured the SHS process on daemon. That time you will SHS on your Linux. Then you will see SHSD is running, right? Let's suppose you have configured the HTTP process. That time you will see HTTPD process is running, right? In similar fashion in your management plane, it is having different types of daemons processes which are running in your management plane. And let's suppose if I'll take example of your IPsec VPN. So for IPsec VPN, there is a one process which is IKE-MGR. This process is running. Your tunnel D, this is the one of the process running. Your key-MGR, these are the different process which is basically responsible for handling your IPsec related traffic. Let's suppose these processes and they are a part of your management plane. Let's suppose any of these processes, they are not working fine. How you will troubleshoot that issue? If these processes will fail in other vendor devices, you have to restart your entire device, right? But in Palo Alto Firewall, you just need to restart that specific process. That's it. You don't need to restart the entire box. Even though you will also get, let's suppose someone has launched the attack on your data plane, that case you can restart your data plane. You don't need to restart your management plane at all. So such kind of benefit also you will get due to the parallel processing hardware. Okay. Now, let me just put some more lights on this data plane component, guys. Okay. So, if I write down the actual architecture or a data path of your Palo Alto Firewall, then it looks like that. In your Palo Alto Firewall, what we have an interfaces stack first. These are your interfaces of your Palo Alto Firewall. So let's suppose interface, they say you Ethernet 1x1 interface, and this, let's say they say Ethernet 1x7. Ethernet 1 till 7, let's say these are the 7 interfaces I have on my Palo Alto Firewall. 1x2, 1x3, 1x4, 1x5, 1x6, 1x7, and this is 1x8. This particular interfaces, they have a direct connection with one of the chip inside your Palo Alto Firewall. That chip is known as a Marvel chip. All these interfaces, they have a connectivity with this particular chip. Like that. And after that, this Marvel chip, it has a connectivity with one of the processor or one of the chip. That chip known as a Liger in low-end boxes. Tiger chip you will see in high-end boxes. And that chip is known as your network processor. Or we can say this also act as a session offloader. So if you are having a Palo Alto device like your 5000 series box or 32 3000 series box, 3200 or 7000 series box, you will see these Liger and Liger chips. Now this chip, they have a direct connection with Marvell chip, and these particular links, these links is known as a joy links. These are the high speed fiber links, guys. And after this, you have a one more chip. That chip is known as a Octeon chip. This chip is known as data plane CPU. All the processing, like your ingress stage, your flow lookup, then your fast path, slow path, everything done by this particular chip. This is known as data plane CPU. And after that, we have one more chip. That chip is known as Jaguar chip. So this is also your FPGA. This is also FPGA. Or this Jaguar chip is responsible for doing your app identification and your content identification. So if you have configured URL filtering and all, your Jaguar chip is responsible for all of them. Now, if I put here, this particular chip is also known as a signature match processor. So we have discussed, we have a three planes, right? We have discussed these planes here. We have discussed these planes, right? So if I'll put them like that here. So we have these three planes, right? Signature match processor. This is your signature match processor, and we have here Jaguar chip. Security processor. This is your security processor, your Octeon chip. This is your network processor, your Liger or Tiger chip. This is the complete data path of your Palo Alto firewall. Just remember. Okay. Now, if I'll go into one of the diagram here, if I open the actual diagram of 5000 series box of your Palo Alto firewall, you will see here, you will get whole idea here. So if you will see this particular block, this block is known as control plane, or we can say it is your management plane. And your management plane is having dedicated cores. It is having a 4-core of CPU, and it is having dedicated RAM and dedicated SSD. What is the job of this particular management plane? It is responsible for your configuration management, your reporting, and your logging stuff. This is the job of your management plane. And after that, we have a switch fabric. So guys, this is your Petra chip, right? So let me just tell you here one point. In some of the boxes, you will see both the chip, Marvell and Petra. Marvell chip has a connectivity with your copper ports, and if you have a fiber port or your SFP plus port, then you have a Petra chip. And after that, this particular, you will see the network processor where you have a Tiger. This is the chip name. These are the internal component, guys. And if you want to do the advanced troubleshooting, you have to know all this particular thing. If you don't know, you will not able to do the troubleshooting correctly. Then we have a security processor. These are the security processor. And if you will see, because here we are discussing 5000 series box. In 5000 series box, you will not have a one chip. It is having three chips, 3 Octeon chip. And these chip is known as a DP0, DP1, and DP2. Data plane 0, data plane 1, and data plane 2. And this is the box who will support your actual SP3 architecture. Which means, let's say you have received 3 packets for same flow or for same session, right? Maybe one packet is processed by your DP0, another is processed by DP1, maybe another process by DP2 at the same time. So this is your parallel processing hardware. So your actual SP3 is applicable into high-end boxes, guys. Just remember. Otherwise, it's just a serial process. And after that, you have a signature match engine where we have a Jaguar chip. So you some in 5060 series box, you have a 2 Jaguar engines, and it is responsible for your virus protection, your malware protection, your wildfire, your URL filtering, your vulnerability protection. Everything is done by this particular engine. Now, in this engine, in signature match processor, we have a 2 algorithm, AHO and DFA. This DFA algorithm is responsible for application identification, because we need some kind of method, right? Some kind of code who can basically take the help of this signature match processor, and he will basically perform the task, right? So your DFA algorithm, it is responsible for your app ID. It will basically, this algorithm runs on your Jaguar chip, and this AHO is responsible for your content identification, like your URL filtering, your antivirus protection, your spyware protection, file blocking, everything is taken care by the AHO algorithm on your Palo Alto firewall. That's how your Palo Alto SP3 architecture looks like. And here I have just discussed the parallel processing hardware, guys. This is the parallel processing hardware. Now let me just explain you the, so as we have mentioned SP3, right? S means single pass architecture, single pass software. P means parallel processing hardware. We have discussed the parallel processing hardware. Now in single pass software, this single pass software is applicable at your CTD engine or at your content engine. Just remember, this is only applicable at your content engine. How it works? Let me just draw one diagram for that. So generally, what happens? So let me just draw like that. Okay, so now if you have seen, your packet is first received at ingress stage, right? Then it will go for flow lookup, which is your session table lookup. Then it will go towards the first path, right? If session is already there, otherwise it will go towards the slow path, right? Then it will go towards app ID, right? And after that, your packet go towards your content inspection. Now in content inspection, basically, in content inspection is done by your Jaguar chip. This we have already seen. On Jaguar chip, your DFA algorithm, it will take care of that part, right? So what happens? This DFA algorithm, it runs on this particular Jaguar chip, right? And if you have seen one more thing here, that particular engine, it is having lots of RAMs. You will see it is having around 4 RAM. Why it has that much RAM? Because what they used to do, when they receive a packet into your Jaguar chip, what they will store that packet into this RAM. They will store the packet here. We have received the packet, and they will store the packet here inside the RAM. And after that, what it will do? Here, let's suppose you are running URL related code. Here you are running anti-virus and anti-spyware related code. Here we are running vulnerability engine code, right? Then here I am running your wildfire code. Here I am running like your file policies code. All these particular database I'm having, these are the signature databases I am having into my Palo Alto firewall. Now I have to basically match this packet against all these databases for scanning purpose. So what it will do now, all these small codes, what they will do, they will load this particular packet from the RAM, and they can able to load that packet at the same time. They will load that packet, they will process this packet, means they will just scan this packet or this particular specific code against the signature database, and they will basically provide the results, and after the processing, that packet go out. So now if you have seen, they are processing this packet at the same time, right? This is your SP3 architecture because this processing happens at the same time, guys. This is your single pass architecture. Why Palo Alto able to do this thing? Because Palo Alto firewall build his operating system like that only. That's why basically they can able to do the single pass processing, and this is your single pass processing, guys. So this is all about for today demo, guys. Now let me just stop the recording. Let me